yeah, from the basic solid. We'll show you guys what is the basic solid here. The objective is the rules of the basic solid in the views. Means what? Means okay, how can change the three-dimensional solid and change them into the two-dimensional projection. So this is the most important objective of this class, and the rules is very important. You should remember this one. So a point and a line. So you guys find a very interesting thing. That's when we do the just like solid and plane, we always tell the point and line on the plane. Yeah, in here the same thing. A point and line, how and curves or curves line. Because in the solid way is more complicated than on the plane. So in this part we will check another new question, just like curves on the solid. So this was the first thing you should know. Okay, for the basic solid, we should remember the projection law. Projection, yeah, just like the limits or just a specification for the solid in this two-dimensional projection plane. Then you'll find a point line on the surface, yeah, of the solid. So here, this is a picture. This picture is showing you guys there is a building, and from this building we found okay, this is a in this part we just talk about basic solid, yeah. So how about this one? We call it this compounding solid. Yeah, it's not just owning a solid, it's a lot of solid, and most of the solid is we call it basic solid. Just like here, you can see a pie, you can see a roof, yeah, you can see a floor. There is a pool, yeah, or some other just like car, tree, okay, or some windows, yeah, a flight platform, okay. So you can see in a compounded solid, you can depounding those parts to the you can depound them into the basic solid, yeah. So from here we will found that for the compounding solid, we used always found is consistent of basic solid here. So what kind of basic solid we used into construction a more complex, just like this building? We called it also, we have this one. So maybe this is just like a house, yeah. Some guys will take a house to living here. But here, we just like the building, we always use this kind of building to working, yeah. From this one, you can see, okay, there's a huge cubic, yeah, and the cubic buildings, just like here. You can see from the windows and also have steels, the windows, steels, and concrete to make a huge, large buildings used for working business. Here, you all know this one is famous in China, yeah? We call it Shanghai. We call it the Dongfang Zhizhu, means a shining ball in the north of China. So this one is just like this building, very interesting, yeah? This one is a tower. Tower for what? You guys knows? Is a television tower. Is a television to use to television to send the signal to the TV. So here we have a tower here. We just like there is a boy, yeah, and this is a tower. This is the tips, and this is just like a leg or ribs, yeah. This is another board. So also for this complicated building, you also can find some basic solid for construction of complicated solid here. And there this one maybe we have in our class we have guys from Mongolia or not. Okay, we know that Mongolia, and also in China we call it we have Inner Mongolia. Yeah, so here is just like a very, very typical buildings for the, for college. Monggu ball is just like, okay, you can see from here, we can see, okay, this one is just like a ball, yeah, a ball, yeah. Here, and just like you have some materials to, okay, construction or a space. This space is used to living also, and this one we have pyramid, yeah, the small pyramid in Egypt. So here, this is a pyramid. So this one is okay, it's very basic because this one is very easy, yeah. This one is very easy than this one and then this one, than those two. So this one is very easy, so we call it the basic solid. We are talking about pyramid, yeah. So it's a basic solid, one of the basic solid. Also, we can use the basic solid to construction a building in the real life. Here, there is in the Nepal, yeah, we call it a tower. It's a Buddhism, yeah. Just like we can see how it's a famous Asian building here. So we talk about those pictures to show you guys. Okay, maybe you find that interesting. Okay, in the real life, we use the basic solid. Also, we use the basic solid, combine them together to construction a compounding. Yeah. Compounding basic solid. So basic solid in this part, you guys, you will, okay, we'll take you guys to familiar with two kind of basic solid in this part. The first one is just to show you in this PowerPoint. We call it the planar solid. Planar means what? You guys have any idea? Planar. Planar means plane. Yeah. Plane means what? Plane means, okay, no curves. All the line, all the plane are straight line. The end, just like here. So in this plane solid, we call it all the plane or all the edge are straight line or plane. No curves. You remember, guys? We call this the planar solid. And this one, because we use a revolving, yeah, revolving. You revolving something, you can make a curve line, yeah. Just like you use the finger to turn circle, the outline of the circle is a curve. So for this one, the second one, the difference with the planar solid is just they have curves. Yeah. So this is a new thing or just the okay, it's a new friend for this class. Because in the former class we always talk about just the straight line, yeah, straight line and plane, no curves. So here is planar solid here, just to show you guys this we call this one for the cylinder, yeah, cylinder 圆柱体 okay, this one is pyramid, yeah. And for those revolving we have the curve plane, yeah. This is pi, this is coin, this is ball, and this is torus. Here you guys will show, okay, we have 1 2 3 4 5 6 basic solid. And the next part we will know that, okay, how about this basic solid, how about the projection in the two-dimensional for this, the first objective, yeah. Here, so first we go into the kind of the solid we call it the planar solid, just like here. Planar solid bounded by plane surface are polyhedral. A polyhedral means what? Means, okay, we straight, we are plane. Planar surface that bound polyhedral are face of solid, line of intersection of face are edge of the solid. and point of the intersection of the line are vertex. So here we have two for construction a planar solid. We have here we have the plane, yeah, we have plane, and the plane with plane we have the intersection line, just like here. Lines of intersecting of face are edge. We call it edge, and the plane we call it face. So this is the face. This is edge, and sometimes the edge they have construction one point. So we call this one vertex. So here we have three elements for the planar solid. So we have the surface, face, yeah. We have the face with the face. We have the intersecting line. We call it edge. And the edge and the edge they accumulate to one point. We call it the vertex. So just like here, one we call it prism. This one is pyramid, and this one. This one, how can construction this one? You guys have any idea? You have one, two. You can use a knife to cutting from the pyramid. Then you have this one, yeah. Truncated pyramid, yeah. We call it just like a platform. There is a platform here. We just use a knife. You cut here, you get the basic solid just like here. So okay, so planar solid and point on surface of solid here. So this one is the planar solid and point also on the surface line is another question for us. So here, solid must be have three-dimensional because solid is not only have just a plane or line. It's a solid part. It's three-dimensional part. Each terms we have facing in the yeah. So here we'll draw how can solid also must be three-dimensional, closed with objective, and filled up with materials. Here, even though it may be a hollow thing, can having a thickness filled with materials. So just like here, we will know that all the in the inner of the solid there is materials. Just like here, those one are materials. And if there is hollow, means there is hollow, yeah. They also have the thickness, thickness wall, yeah, here. So draw a planar solid or draw the edge. How can draw a planar solid from here in the two-dimensional questions? Here, draw a planar solid or drawing the edge. You can see here how many edge? 1, 2, 3, 4, 4. 4 edge, and then 4. There is 4. This around here there is 4, and then at the bottom one is 4, so it's 12 edge. And this one 1, 2, 3, 4, 6. There has 6 edge. And this one will also have 8 edge and 12 edge. So you can know that how can draw a planar solid. That is very easy because we always use edge to construction a planar solid. So when we draw a planar solid and draw the edge of the surface or the vertex in the views, the visible edge drawn in the real life, the invisible edge in dashed line to show the visibility. Just this is the same thing we talk about in the visibility or this with invisibility in the chapter 5 for the line with plane, because the line will always blocked by the plane. So here you can see, okay, then we have 1, 2, 3. We have 1 and 2, two kind of planar solid. First, just like a prism and pyramid. This one is a spatial pyramid. Okay, we don't talk about in this one. So here, the first we move ahead to the prism projection. Prism projection in the 3D. Okay, prism, just like here, you get the projection in the three-dimensional projection. Okay, so first we have look here. This prism, this odd edge on the on this round around here, 1, 2, 3, 4, 5, 6, 6 edge around this prism. How about this edge? We call this edge for what? This one edge, is this edge is parallel to V and parallel to W. So this edge is perpendicular to H. Yeah. So all the projection for H for this line on here is accumulate to one point. So we call it H point view lines. So this 6 edge are H point view line. And this plane is parallel to H, and the bottom plane also parallel to H. The two parallel to H, and this plane and this and the back of this plane is parallel to V, and this two plane, another two plane, these two plane are perpendicular to H. That you can see from this picture. Use the plane line, and we talk about the spatial plane and the spatial line in the three-dimensional. So all the prism you put this one in the three-dimensional or just the first color of the projection systems, you will find also have spatial plane and spatial lines here. Okay. You can see here. So for how about the projection on this one? On this on H, on V. So okay, so this plane and this plane a construction and accumulate one line. And this plane, yeah, is the same with this one because this one is a parallel plane, and these two plane are construction here and this and here. Okay, so how about the projection to H? You guys will find what kind of shape when you do the projection on this on H projection plane for this one. So you have any ideas for the prism on the H projection? So you guys, can you answer question or can you hear me?
Yes, Lodge.
Okay, so when you do the projection, this one, okay, and this one, because we talking about this, all the edge line are perpendicular lines. So all the projection here is a polyhedral, yeah, polyhedral. Polyhedral is a 1, 2, 3, 4, 5, 6, 6 edge polyhedral, and on this direction is a little bit difficult. It's just like okay, a line in the middle, yeah. And this plane is same to this plane, and this plane is same to this plane, all blocked by this plane. So on this direction is like here. You guys have any question for the projection of this one? We call it prism. Remember the prism's projection because it's basically solid here. So here, yeah. Then we also talk about okay, when to do the three projection system of the prism, we call it the wireless of this prism is equal to this one. Yeah, yeah, the wireless is equal to this one, and the highless is equal to this one, and the wireless. This one is wireless is equal to this one. Yeah. In Chinese, we call it the length is equal, the height is equal, and the wireless is equal for this prism on the two-dimensional projection system. So you can see here. Yeah. We'll show you guys. Oh, okay. Remove the marks. We'll show you. Okay. In cleaner, more cleaner presentation here. So for the prism, we remember this one. Okay. Here, the most is okay. We can find a polyhedral in the edge, and then you can find okay. This one is equal to the wireless here. This one is equal to the wireless here. This direction. Yeah. So here, because distance, yeah, we have distance on this direction to the projection is this distance, yeah, and the distance to the projection on here is distance. Outline and here, yeah, the length. This one is this length, this x. Okay, h. So this is a prism projection. Prism, we have different kind of prism. It depends on what? It depends on the bottom, yeah, the bottom and the top surface. Depend on the surface, have the edge. How many edge of this one? We have 4 edge, we call it 4 edge, 5 edge, and this one is 6 edge. Also have a line edge, different kind of edge construction of prism. Yeah. Here we should finish the, okay, we call this one, we call this axis. This axis make this part into a two similar parts. So we use the dash point line. You remember? So when we cannot see a line, we use the dash line. And this one we call the point and the dash line. We add a point in the middle here. You can see from here. We use this to do the axis. Axis means what? Means this axis make this two part into the same part. Okay, so this is a prism projection for this question. So another one, we should go directly to the point on the prism. Point on the prism is here. So you can see here point on the surface. Remember the point on the surface. On the surface, yeah, means what? Means okay, you the point on the surface, not in the inner part, just on the surface here. So make this question very interesting. So you guys, okay, the point on the surface. So a plus 1 comma is on this part. Yeah. So how about the a, because it's on the surface, yeah? You guys remember, you can change this one. So we have how many surface on the outside? It's surface 1, surface 2, and surface 3, and surface 4. And we have 1, 2, 3, 4, 6 outlines, outside surface. Yeah?
Yes.
So how about point A on the another two projection? You guys take maybe 2 minutes. Take 2 minutes to find the answer by yourself. You should remember this one, and this one in your brain you should construction this one, and the relation with this one and with these three projection construct them relate them together, so you can take the answer. We will give you answer 2 minutes later. You can try it by yourself. Where is the point A on H and on W? Okay, so where is A? On the edge. So A, because A, you will see, okay, this plane, this projection of this plane is, and this is this line plane, and this plane have the same projection as V. So A is here, means A is on the front. If A on the back, means A is not visible. So here A should be on this edge. Yeah. So you can use the point projection law to here to find the question. A should be on here. Because A is on this direction, you look from here. A is not visible. Okay. Just like here. B. Okay. We talk about B is on this plane, so all the projection should be located on this two line. Because B is not visible, so B should be on here. Yeah. Then use the point projection law, you can get B is there. B, because see from here, B is visible. So another question is for the lines. Lines on the prism is there. Okay, you have a line here, point A, and here. You can this line run across the surface 1, surface 2, and surface 3. So you guys, we talk about one line. You just to change the line projection to the point projection. Then you line them together. You can get the point of the line projection. So also this line is on the surface of the plane. So here you can see there is how many intersection points. So we have 1, 2, 3, and 4. 4 points on the surface of the solid is there. So you guys take okay, take a 2 minutes to finish this one. Okay, we talk about when we finish the lines, we should get the point first. So here, A is we already know. So we have the intersection point here, and the intersection point here, and another point is there. So you do 2 times, 4 times, 4 times of the point here. You can get the result. Point 1, yeah, you can get the point here. This is the answer. You can first you can know this point should be on this one. Yeah, point this point should be this one, and this point should be this one. Yeah, and here should be here. You extend here. Then you get the point should be on this direction. You use okay. You find the point this one. should be on the here, yeah, and this one should be here, and this one should be here, point A there. So you get the result. Use the 4 times of here. In this questions, we'll also find okay in this one, from this direction, this point, yes, make this the point. Make the lines into 2 parts, and this part is visible, and the back part is not visible here. Yeah, this one is not visible here. You can see from these pictures, let's see the lines and point on the surface of the prisms. Here, we just look here, we just only the 6 edge, yeah, 6 edge prism. Okay, we take another one is a 5 edge prism. Just like see here, you can see from this picture, you represent that this is a 5 edge prism. 5 edge prism is the difference with the 6 edge prism. Just the difference is make the bottom one is 5 edge prism, and this one, okay, you can see the projection A on V on W and on H. So we also have 2 horizontal plane, the top and the bottom, and then another the back plane on this one on the back one is also horizontal plane. It's also a parallel plane. We call it front plane. And another 4 on the side plane are the is perpendicular to H. We call the H perpendicular view plane. Yeah. So we have a spatial plane construction of pentagonal prisms. Okay. So this one is a pyramid for the basic solid. The difference with the pyramid, just like do not have the top face surface. We only have the vertex because the pyramid, okay, construction by 1 2 3 4 4 1 2 3 4 1 2 3 edge, the edge, and the bottom plane and the 3 edge construction of vertex, the vertex here. Just remember the side plane, yeah, edge, and the bottom plane, and the perimeter point here. For the 3-dimensional, just like see in the pictures, and the projection on the H on V and on W is on this one. We can see from this pictures is there. So here we can see in the bottom is a rectangle, yeah. On another one, you can see this edge on the bottom and the plane ABC is a horizontal plane. So ABC plane on V is a line, and on the H on the V on the W is also a line because this plane is a horizontal plane. The vertex is S. Yeah, you can see from here. You can see S on this direction. Then you can see okay, this H is in the middle of this part, and the plane SBC plane, we call it the side is perpendicular to the W because SBC on V projection is construction line. This is SBC projection on the bottom on this direction. SBC is perpendicular to W projection plane. So we call it the W edge view plane. Here, SBC, look at here. So all the projection for the pyramid, you remember this one? Okay, you remember this one. We'll show you guys again. First, okay, we do the bottom one. Bottom one is the rectangle plane on H because this one is a parallel to H. here. You look at here. Okay, so because this one is horizontal plane, so you on the A, on V, and on W is accumulate to one line here and here. And then you can find the vertex line, and then you line them together to find the H. On H, just like here. And this one is okay. This H is on the middle of the ABC. ABC, this line A is on the middle point here, just like here. SBC, the backplane SBC, on this one is accumulated one line, just like SBC. So this plane is perpendicular to the V, to the W. So we have okay, one horizontal plane, one perpendicular plane, and okay, you can get the H. Also at the same time, you can get the pyramid here. The same thing that's for the point on the surface of pyramid is a little bit difficult than on the prism, because okay, from here we should use the helping line. You guys find a point 1 is there on the surface of SAB. Yeah, S. Remember on the surface, so should on the which part of this one you should remember. Okay, on this direction, what point 1 is there? How many points should we have the same projection on this one? Is okay. You can look at here. Maybe point 1 should be on this plane, also or on this plane. So which plane should be point 1 on? You can use the visibility to tell. So point 1 is visible. So point 1 should be on the SBC plane, not on the SBC plane. So you guys, can you tell me how can you use the helping line to tell the answer for this one? The point 1 on the surface here. You know how can get the another projection on H and on W. So first we talk about in the plane. We in the plane so said okay, how can determine the point on the plane? You should line a point. How can tell the point on the plane? We can use this point should run across a line, and a line belong to this plane. Yeah. So you should find a line, and this line also belong to this plane. So there, how can construction line belong to a plane? You run across the S. Yeah. You run across S, and then you line S and point 1 together, you get the point another projection on BA. You get the BA there, S is there, so you can line here, you can get the point 1 is there. So this is the answer. I can show you. And another one is use a cut life. This one is you have two methods. You remember have two methods of construction of plane of this one. So first, you just you guys can imagination. You use a knife to cutting from point 1, and cutting a plane to parallel to the ABC to the bottom plane. So you get a line is there. Yeah, you cutting line here. You get here intersection point here. You just get a line because this line is parallel to AB. You can get a line here. Yeah, here you get a point 1 here because it's just cutting from here. You get you can see you can get a small rectangle. You can imagination what I okay. You use a knife the cutting through point 1 to make a knife parallel to the bottom plane. You can cut in a small rectangle just in the bottom, just like the knife, the cutting plane is that here. So this line is parallel to BA, and the point 1 should be on line on this line. So point 1 is there. So this is the answer. Then use the 45 lines, you get the answer point 1 here. Point 2 is on the line of SA. So on this direction, you can know point 2 should be on SA. Yeah, here you can use the because it's on edge. You can just use the point on the line. So on another side should be also on the line. So extending the line, point 2 is there. So point 2 is there. Point 3. Okay, we talk about maybe a point on the surface on V. Maybe you can point through to one on this plane, also point one maybe on this one, maybe on this point. So we have 2 points have the same projection on V. But point 3, you can see, okay, you guys found point 3 on the bottom, so it's on the bottom plane here. So how can get the construction the point 3? You also run across 3, just you use a life. To cutting the projection on SC, you do the parallel line here, you get the 3 should be here. Yeah, use a life. Cut here, 3.3 there. Because we talk about because point 3 on the bottom, yeah, this one is accumulated to the SAB. So you can also use the accumulating part question of here. So point C, point 3 should be on here. Yeah. Here is the question here. Yeah. Here is the answer for the point 3. And I also have a line, the red line. You get this point on the ASASB, so point here should be here. And the point 1 is there. Point here, you can use the, here you can get the another one is there. And this line is on the bottom, you can see this question. So you can use the solo, this helping line to construct on the V. Remember this one, this point make the line, this part is visible, and this part is not visible. You can see the answer, okay, here. So we do the summarize here. In a pyramid, we have 2 methods to construction a point. You have 2 methods there. Okay, the first one, point A, is here. So you can use a knife cutting, then you can do the parallel line here. You can use the helping line, run across to A. You line them to get the point C there. Your line C is here. So line CB, you can get the A should be on this one. So A should be on here. Remember this one. So the first one, we use the helping line. Helping, you get the CB there. You can use the A there. But you don't, okay, on the third one, you don't need to do the C and B. Because we use the point projection law, you can construct some point on W very quickly. You remember the point projection law here. And another one is you cut, you just your cutting knife, just point A. You get a knife to cutting from AB because this plane, this line, this plane is parallel to the to the bottom. So in this line, MN is there, so you get MN should be parallel. MN should be parallel to here. So A should be on the line here. It's the same thing, the same question. So there, here we can use the 2 methods, guys. You remember? No matter what you do line or do point, you first do the point projection. Yeah, remember. If you want to do the line, you always to change this point, all the point here. Yeah, change this line to 1, 2, 3, 4. Change the line to 4 point. Then you do 4 times of point. Use the visibility from this direction. You can see here, this one is blocked by this plane. So from this point, make them into 2 parts. Okay. So this is 2 methods there. show you the question here. Okay. The planner, okay, planner systems, planner is very quickly, we finish the question for this one. So how about the revolving, uh, the revolving solid, just like a revolving, we call it that's like turning around a circle to make a solid. The revolving always we have the curves on the surface of solid, just like here. You have the one moving line, we call this moving line, and the moving line to construction of revolving solid is there. The moving line we call it the mother line, and the around that circle axis we call it axis. And another surface not on the on the not on the outline, we call it the element, just like here. We'll show you here. This one we're revolving, just like this is just like okay, we have the axes, and we have the general tracks, and you use the general tracks to turning around this axis to make a okay solid. We call it okay. This top face, the bottom face, the latitude, and the equator element. Element means the The difference with the general matrix is any shape of the on any position of this general tricks. Here we can get the construction solid just like here. So we just like a pipe, a pyramid, ball, and a torus. Revolving solid represented by turning direction, just like a quarter out counter line on the view. Just like here, revolving is in line with the solid with the curves. Just like here, we can get the here. Okay. Look at here, we can have the cylinder projection on here. This we call it, okay, look at the boy. The outline is outer counterline. Yeah, this is outer counterline. So this counterline is a shape with the general tricks. This line is the general tricks. You need this one. So the outer counterline. Yeah. Revolving solid represented by the turning direction outer counterline on the reverse. Yeah, this is outer counterline. So revolving just like here, we can get the outer counterline from here. You can use a common use a revolving solid just like here. We have the prism, we have the cylinder, coin, ball, and torus. Four kind of here. You can see from high, guys. Okay, you can use a line. How can construct a column? Yeah, just a coin and a sphere. We call it this four are the four general revolving solid. You guys can see from here, we will use the red one. We call it the general tricks. Yeah, the red one. Yeah, there. Then for the cylinder, use the general, just like a line here. You can turning around the axis. Is there? You're turning around here. Parallel with the and then turning around with the surface and the top bottom plane. column surface generated by the line revolving around the axis to get the cylinder. Cylinder, we have three parts. You guys can see from this picture, the top surface and the bottom surface. Yeah, you can see from this one. We can see from the projection. You guys see, okay, on the edge is one kind of projection for the cylinder. It is one kind of shapes. You guys have any ideas for this one? For the projection on edge, is what kind of shape?
Circle. Circle.
Is a circle, yeah, that's right. Is a circle. So all the projection on edge is a circle. On here is a rectangle. On here is also a rectangle, and this rectangle, and with this rectangle is the same. Is the same one. Is the same. And this one is a circle, yeah. So the difference with the planar solid, we have curves on the surface, yeah, curves. Here we call this two lines the outer counter line, yeah, outer counter line on V, and this two outer counter line is outer counter line on W, yeah. So outer counter line we talk about it on the V front, on the front on V. This line this line. These two lines are outer counter line on V, and these two lines are outer counter line on W. Make this two line is just the most sideless on the side, outside of the cylinder here. Here we do the projection, show you guys. Okay, so first on H is a circle, on V and on W is a rectangle. We used dash point line, dash point and line, and the line number we use to do make this one, make this two part and the two part, same part, yeah. So first you do the circle, do the red line. Red line we call it the axis, yeah, red line. Then you do the bottom, and this is for the rectangle. This length is equal to the diameter of this circle, yeah. And on the V we call it the V outer line, outer counter line. This is for V. And these two lines are outer counter line for W. You draw this one, okay, you get the answer. We talk about it, okay, this one is a cylinder, and we put this one is have the plane, the top and the bottom plane is parallel to H, but sometimes we also to change the direction on the projection. This one we call this is on H. This one is parallel to V, and this one is parallel to A. V. This one is parallel to W. This one is parallel to H. So you change the cylinder have different direction. You get three projection. Yeah, different kind of projection for the cylinder. It's like here. So this one we call this axis. Yeah, this one axis is a perpendicular to H, and this one we call is axis of this line is perpendicular to V, and this line is axis perpendicular to W. So this is answer for this one. Okay, so you can see from the projection for the cylinder, you from a crossing knife, you can use a crossing knife to cutting from the cylinder, make them four parts, front and back, and left and right. Front, we change the front, left front and right front. Back, we had a left back and a right back to make four parts. So just like we have the axis show you, this is left and this right. This is left and this is right. This is front, this is back, and this is front. This is front, this is back. This is left, this is right. So you should use the left and right to the visibility. Yeah, you can see from this animation for you guys. The first is the yellow part is a button. Button is here. Yeah, you can see. Okay, button is on this one. Yeah, All the projection is on this one. Yeah, see you for this pink one, pink yellow one. Okay. This is the bottom one. The top one is on this one. Okay, is on this one. Yeah. And the bottom one and the top one have the same circles and accumulate one surface on here. Just show you guys here. And the the front part of the circle is this one. Yeah, is this one. And all the projection on V, remember, is this part. This means front. This means back. You should remember this one is okay. Is this direction. You just turn it around. Is this direction. So look like here. Look at here. Is back. Back is this one, and front is this one. Okay. So how about the back one? Back one is this one. Back one is okay. Is also this one is blocked by the. Look at this direction. The back part is blocked by the this by the front part. And here you can see back part is there. This is for back. And also have the left. Left is this part. Other part on V is this one, and the left part is on this one is this direction is this part. How about the right part is this part? Yeah. So you guys, okay, this is a question for this is, and for the outer counter line. Okay, these two are outer counter line, outer projection on the on the here. The outer counter line, remember, all the line on the outer counter line, all the projection should on this direction. On this point, yeah. And then here, another two, and the side line is the outer counter line. And all the projection accumulate to one point is there. Here. Okay, we'll show you the cylinder projection. I also tell you guys the front, back, left, and right, and also the outer counter line on V and on W. You remember this rules. Remember this rules help you guys to find the answer. How can construction a surface, the plane point on the surface? You guys, okay, see here, point A is on the outer counter line, yeah, here, yeah. So point A on the outer counter line, you can see from here because this one line is outer counter line. It's on the diameter is here. So where is point A on H? You guys remember? Where is point A on H? Where is point A? You guys have any idea where is point A on H? Because it's on outer counter line, it's on this one line, so all the projection is point A should be here. Yeah, because A is on outer counter line. It's on the outside, so point A should be on the corner outside of point on the also on the axis here. So you can use the because if you on V is on the outer counter line, so on another plane, remember this point should be on the axis. You can see from this picture that it's very easy to find A is on the axis of this on the V on W. Yeah. So here point B is on the here on the front part. Yeah, on the front part. So point B should be on this part, yeah. All the part, remember, all the points on the surface accumulate one line on the circle line, yeah. The point B is there because the point B is visible. You use it here, you can get the answer. P point on the W is there. Point C is on the this direction. We call this is a V out counter line. So V out counter line C should be here, yeah. Because on V, this is on the outer counter line. So on W, on W is on outer counter side line. So on V is on the axis. axis. Yeah, axis. So D, because D is on the back, on the bottom, on the back, sorry, on the back, on the back part. So D is not visible. So D should be on this part, but not on this part. Because we say about how 2 points have the same projection on here. You can use the visibility to tell on front or on back. So D is visible. So D should be here. This is D. Okay. D also from this direction, D is also blocked by this part. Yeah, so D is not visible. So you write the shape like here, letter symbol like here. Another one is a line on the surface of a cylinder. We talk about when on the surface of a cylinder there is a curves. Yeah, you can see from here. You can see all the points on on H. Remember, should located on this line. You can use okay. Maybe A is visible. A is there, not here. B is visible. B is not here, but here. C is visible. C is here, not here. D is visible. D is here, not here. So we have 2 points have the same projection. You just remember you can use a line to run across this cylinder to get a projection of V. We have 2 points have the same projection. Yeah. So use the visibility to tell on which part, front part or back part. Yeah. So this is a line on the solid here. We'll show you because this is curves. You curves, there is no straight line. You use the curves just to finish this one. You can see, okay. Another question. Line AB is a line on the surface of this cylinder. You always know the point A and B. And please construction on H and W. How about the line projection? You guys can do it by yourself. Maybe take, okay, 3 to 4 minutes. You remember this one? You can use the, okay, we talk about the point construction line. You can maybe, and this is a curve line, so you should add another point. Yeah. You can take maybe several minutes to finish this one on your book. You should remember this point on the surface. This is very important, okay. And this line is also on the surface. So, okay. First you should know point A and point B should be direction on here. Okay, it just like a knife cutting from here. You should add another point because we talk about this is curve line. You should point C there. Point C there. Point A is on here. Point B is on here. Yeah. And 3 points is not enough to construction of curves. You add 1, 2, 3, 4. You add another point to help you guys to finish. The point 1 is there. Here. You can see from the C, make these two parts are different from here. Look at this direction. AC is visible. CB is not visible. You see from here that difference is there. So for the curves lines in the planar solid, we do not add point to the construction the line. But for the basic solid, for the revolving, because only one point cannot give the direction. It's like here. See from this picture, AB and CD, you can see, okay, AB is a curved line because AB, this CD is a straight line. AB is curved line means, okay, on the curved line, just like AB is cutting from this direction, so AB is you cutting from the circle, use a knife here. And this one use a knife to cutting from cylinder just this direction. You can use, okay, this one help you guys to imagination. So AB is a curved line, CD is a straight line, yeah? You see from this picture. If you cut from this direction, cut here, you get a circle, yeah? The CD AB is a curved line. Here is another question for this one. Okay, A and B tell you guys, okay, already knows. And how can show you the finish the under another two on H and on W. Maybe you guys can find. First, you should get how many points, spatial point, point 1, and there is also spatial point, there is a spatial point, there is a spatial point. 4 spatial points, you already know. So you construct 4 points, then you add another 1, 2, 3, add another 3 points to construction the curves. Then you finish this question. So first you can change, yeah, can take your times to finish this one by yourself in your draft paper. Okay, we talk about the first point A is on this direction, and A is not visible. Means what? Okay, on this direction, this is A is not visible. Means A is on the back part. Yeah, on this part, because see from this direction, you just like a cylinder. This one is just like a cylinder to on this direction. Yeah, it's a cylinder to perpendicular to V to W. Yeah. So from this direction on V, so A is on the back part here. Yeah. So A is on the back part. Your A is on the back part. Back part is this part. Yeah. So A should be on here. Then you use 45 lines, 45 line hairpin line to get the answer there. So A should be this part. A is not on this one. So use the visibility to tell on which part. First, you should distinguish this one. So B, because on the out counter line, so B should be on the axis line, and on the here should be on this one. And C and D you can use extending all the tails on the front part. So front part is this part. Then you line them together. Okay, you get the point A. This one use LE. You can also use extending here this direction and extend here this direction. You get this is X, Y, this is Z, X. You helping 45 lines. Use the 45-degree hairpin line to construction another point here. Point C there, point D there. You line them together. But we cannot construction, so we add another two line point. And also add 3 to help you find another, yeah? So from this direction, you should know, okay, from this direction, we also have the H. On H means C, make the part from this is the top part, yeah? And this is top part. And C3D, this line is not visible, is blocked by the top part. So C3D, this is a dash line. You can see, okay. Because, okay, you remember this rectangle is not look at this direction. So this is H. The top part is visible. The bottom part is not visible. So C, look at here. This one this is the top part. Below C, all the lines are not visible here. You can see these questions. Okay. Also have for the cylinder, we have the coins. Coins here is the coins also have composed by coin surface and bottom plane. Coin surface is outer surface. Projection on the edge is a circle. Yeah, on another is a rectangle. Is a rectangle here, and these two rectangles are the same. And how about the steps for drawing a projection of a coin? First, draw the axes. Then draw the bottom, and also draw the bottom line of this rectangle, a triangle. Then you draw the vertex. The finish. This one. Okay, for the projection, we also have this one is called the bottom surface. This is the V. This is the V outer counter line of V. Is these two lines, and then this is and then these two lines are W counter line. W outer counter line. Outer means what? Means the outside. Counter means the is this one. Also, we talk about when you find this point on the outer corner of W, so you find this point should be on the x-axis. If you find a point on here, so all the projection of W should be on this line. Remember, this is the rules for the revolving solid here. Here, okay, we can see. Also the same thing, we can change the coins and different direction. Just like here, you can change the coin and the axis is perpendicular to H. And this one is perpendicular to the W, and this one is perpendicular to V. We have 3 direction. You first can get the construction, the projection of the coin. You first to look at okay, on which plane is a circle, means this one is parallel to which plane. So here, we also to do the analysis. Here, bottom is a horizontal plane. The vertex here is on the middle of is a circle, yeah? Is a circle line, is a circle point. And the cone, yeah, the cone surface. This one is a back, and this one is left, and this one is right, yeah. And the an outer counter line is there, outer counter line is there. So you can finish this one. You can change the left, right, and back and front. Okay. So for the example is there, you can get the projection of the coin here. This one and this one and this one here. A, B, C, and S is the top point. And the point 1, if the on the outer counter line, so point 1 should be on the axis line. And the axis line, we have axis line here. Yeah, axis line is there. So you should remember point 1 should be on the axis line. So this line is this line. Remember, you can change this on this direction, change on this direction farther. Yeah. So this line is this line. And this line is this line on H, on V. Yeah. So point 1 is here. For the point on the surface, we can use the element line to method. The point 1 on here, you can use just a knife to cut here. You can get a circle. You can use also a line here. We can use a line there. you should get point 1 should, because point 1 is visible, so point 1 is on this part, yeah? On this part is visible. So this one is on here. You line the circle S is this one is S. The line here, you extended point 1 is there. So this is answer. Yeah, here is answer. This is a question. You can use the 45, get the answer. Another one you can use live, the cutting from here. Cutting from here, just like so, you get a small circle on H. So this one, you extending the line here, extending line here. Yeah, you get the circle length is this line. Circle length is this line. The circle length, the circle diameter is this line. The line here, the point 1 should be here. It's the same thing. So I have two methods you guys can find. You can use your vertex to construct a line. You can use a line. You can use a cutting plane to get a circle here. Just like here, we can see how about the curves lines on the surface. Just like here, you get a point A, B, C, D, 4 points on the coins. Just like here, show you. There's a circle line. So you guys can take maybe 5 minutes to construction the lines on this circle by yourself. You should remember this method. Okay, this method. And this method also here. Also some special points here. Maybe 4 minutes to construction to in your draft paper. Okay. Okay, we'll go ahead to. So first, we can see as two special points, point D and point C. Because point D is on the outer count line here, so point D on the outer count line means point D should be located on this line, this axis line. Yeah, and on this line. You can see because point D on the outer count line, so all the projection D should here, and use 45 line, you can get the D should be here. Get a D first here. Then you can see is on the axis line here. So C should be on the outer count line of this one. C is visible, means C is on this part. Yeah, on the C is visible, so C is on the front part. So C is there on the here. Then you get C is there. So first, when we look at this one, you get two special points at first. You also can get point A at first. Point A, you can use, okay, cutting a knife here. The diameter is this one. You extend this one to have the, this is a diameter, so you can get the answer here. Point A is on the front part, so A is there. Also, how about the point B? You can use, okay, point D is on here. And point C is on here. Point D, you can use a line them together, and then you get a line here. C, D there. So from the direction, look at here, this direction. And here the projection for the H is the top, and from the H, look at here. All the points are visible. You can see from this direction, you can see all the because no block. So but from this direction, CD is not visible. Yeah, CD is not visible, just like here. It's blocked by this part because CD is on the back part. You see from here. Okay, this is the answer. CD is not visible. Use the dash point line. We should understand what I am saying here, because this is a little bit difficult for you guys to understand at the first steps. But you finish them, and then you change. You use in the three dimensional, you use the imagination here. You can see the question. I think you can understand the question very quickly. Here are the same thing. You can see, look here. First you get point A there, you get point B there. Okay. Because B is out on out counter line, so B should be on the axis line on another two projection plane. See there, you can get, okay, 1.1. Then you use the another 1 to 3 4 points to get the circle life. Then from this direction, we know here, we put the rectangle. Okay, this part is not visible. And another part, we can use the visibility to use the point C to do the visibility is there. Okay. You finish the question there. Okay. So all the point on point from here, we can see is visible because it's from H. Yeah, from H is on this part and from C is this one. Is this one we can see from this direction. C make this one is front and back. Yeah, front and back. C is front and back this direction, so back is not visible. Another third one is the sphere. A sphere we can see here is a boy. Yeah, sphere is a boy here. Sphere generated by a circle. Yeah, here just now we can see the general matrix. A circle around a diameter. Okay, then you get a sphere. Okay, for the sphere projection is very easy. Yeah, all on the three projection are circle, and three same circle here. All the circles three are the same. Then you can see a sphere. The first you first step you draw the axes. Then you draw the outer counter line. Then finish. See here, the diameter there, the outer counter line on V. Yeah, this is outer counter on V. This is outer counter line on W. This is outer counter line on H. This around the diameter, yeah, you get three circles, and makes these circles just like a parallel to H, parallel to Z, parallel to V, and parallel to W. Yeah, just like here. The pink one parallel to V, this circle, and the orange one is parallel to W, and the brown one is parallel to H. Yeah. So this is the question here. Yeah, we have outer contour line, three kind of outer contour line. On the sphere of surface, on the surface of sphere, we use a cutting knife. Cutting knife here, around here, you get a small circle on this direction. You can use, yeah, here. This line, the blue line, is the diameter on this one. You can see a new knife cutting a board. You get a circle on H. Yeah, point 1, because it's visible, so point 1 is on the front part. Yeah, we also use the line point A and D. Also, I have curve line on the sphere. You guys can take, okay, maybe several minutes to finish this one in your draft paper. You remember the yeah, this method. You cutting here, get a circle line and use the visibility to get the answer. Okay, the first one we should know A is on the outer contour line, so A, the projection should be on the axis line here. B is on the axis line, so B should be on the outer contour line on V, on H. Yeah. C is on the outer contour line on V. You get the point A is there, and you get the answer is there. Point D is there. Use a cutting knife, just like here. Distance. Remember, distance is the diameter of the cutting knife. The cutting circle line. Here, D is there. So you add a 1, 2, 3, 4, 3 axis point, 3 assistant point. Get a construction line, then you line them together. You get the answer. So first you should okay tell the visibility here. B part make the point on the top is visibility, and the bottom part is not visible. And from this direction, point C make this line is on the visibility. This line is not a visibility. So you can use point C and point B to tell the top part of visibility. point C is right, left part is visibility. You get the answer here. Okay, this is the answer you finish. Then you get an answer, show you the answer here. To the visibility, so point B make the front, and the top and the bottom. Point C make the left and right. The last one we call it torus. The torus is just like a ring. Your ring or just like a your ring. Okay, we have those. You can imagination with a circle parallel to the axis line. This line is parallel to the circle, and then you around this axis line to turning around, you get the circle like here. So generation is totally generated by a circle revolving around the line in the same plane. Remember, this line is have the same plane with the circle, means this line is parallel to this plane. Okay, so you get the answer. On this direction, we get a outer counter line is there. So first you draw the axis, then you draw the circle, have the in the circle of the generics line, the circle. This one you have the circle, the circle turning around this axis. The center of the center of this circle. Then you draw the this two small circle, the mother line is circle. Then you turn around the outer counter line on the top and the bottom. You have see the you have small circle, this one, and the outside circle on this direction. You can see, this is the outline or the outline, and the inner circle have the outer counter line here. The outer circle have the outer counter line here, and this is on the front. This one is on the and this line is also make the left and the right, the inner and outer circle. This part is the inner circle surface, and outside is outside surface, just like here. This one, the green one, and the blue one is front and back, and the red one is in the inner part, and this one is front and back. You can see from this picture, you can see you make this torus different kind of part. Okay, see from here. The front, is visible, and the front and the green one is visible. The red one is not visible, and the blue one is not visible. From here, the green one is visible, the red one is not visible. So from this picture, you can see, when you see front and see back, you can see the green one is visible. Remember this one? You can finish the question very easily. see here, you can see the point on the torus, a little bit difficult. Point K on the outer count line, so point K should be on the axis line here. Then you get a point K on another axis line here. Point P, A and point B is there. So because this one is too difficult, we do not to require you to finish this one. So skip this one. So this class we talk about the basic solid. Okay, you guys found this is a little bit different with the line and point, and also have the make it more difficult. But I will natural. The difficulty is just as your first step to do it, but you repeat it by exercise. You will find, and always you use this PowerPoint to do the review. You will find it's not very easy. It's not very difficult. It's easy than line and point, I think. So this one, we finished the the point, the basic solid just for the for the 6 kind of basic solid for the projection. The different part, the difficult part is the second objective. It's just a point and a line on the surface of the solid. We have 6 kind of the different kind of position for these questions. So you guys do the review for this PowerPoint, and also to do the homework to do the familiar with the question of this one. Is we have 4-page homework. It's the same thing with this. With the exercise we talk in the class. Then we finish this one, and then we finish the next class. In the last class, we will do the exercise and also do the review. So all the exercise we will give you the answer in the last class. Then when we finish all the class, we will prepare for the final examination. Okay, so for the solid, basic solid, we finished the course today. You guys can take the PowerPoint and also take the video to finish this question. Yeah, I show you answer. Your answer is Meng Jun. Your answer is not correct because A should be on the front part because A is visible. You remember this, guys? Okay. You should then you go back to the PowerPoint to find the correct answer. Okay, so today we finished the class with you guys. Understanding easily, but I think maybe it's a little difficult for you, especially for the online courses. I do not like online courses because I do not have all of you guys' response to my question. You have no answer. I don't know how about you if you really understand what I have said. So wish you guys have any question, you can ask me. Okay, I wish. Okay, so today class we finish it. Yes, 100% agree with you. So, but the virus, virus is so terrible. In China, it's so strict with this one, so treat this more seriously than other countries. So I think maybe the difficulty for you guys to come to China, maybe when the virus is killed by the people. So okay, so finish today's class. Wish you guys have a nice day, and see you next time. Bye bye, bye bye.好的，再见。